Welcome to Big Data Made Easy. In the second part of the series, we'll be using Spark. Spark is a very powerful data processing engine that offers high speed of data processing, which is very important in the case of big data. Spark is based on the concept of in-memory processing, which allows for the data to be loaded in the memory and processed there much faster. Spark can be run in either interactive mode or application mode. We'll start with interactive mode, and then the last two tutorials we will learn how to create applications with Spark. Also, we need to know that Spark can use either Scala or Python. This specific tutorial is based on Python. We explore data frames with Python. We're going to learn how to create a data frame, how to load the data into the data frame, how to manipulate the data, and how to store the results back into the cluster. Before we start, make sure that you check datapower.com/dataframes HTML so you can download all the necessary files for this demonstration. Let's start. The cluster is up and running. Make sure you have selected Spark when you clone the cluster or when you create a cluster. If you do an ls, you'll see that we have two files, customers.csv and customers.json. A cat on customers.json will show that the file has several records, and these records are customer ID, first name, last name, and so on. If you do a cat customer CSV, you will see again this is a comma separated values file that has several records. It also has the column names. We have already moved these two files in the cluster. Let's check. Hadoop fsls will show you that we have a directory called Spark. Then Hadoop fsls Spark will show you that we have a subdirectory called df or DataFrames. Inside the directory, you can see customers.csv and customers.json. Let's start Spark with Python by typing PySpark. Python prompt will show up. Let's create the first data frame called customers.df. This data frame reads JSON file, so spark.read.json. Here we place the path to the customers.json file. So I'm copying and pasting it here. Make sure double quotations and parentheses are placed properly. Hit enter and customers.df is loaded. If you do a customers.df.print schema, you will see that the fields in the customers.json file are properly loaded in the customers.df data frame. Now let's do a customers.df.show to see the records. We can create a list of records. To do that, we use the command take. For example, first three equal customers.df dot take 3. We will create an array of records. If you do first 3.show, you will get an error. So if you just simply do first 3, you will see these records. Row, first, another row, and another row. Type first 3 will show you that this is a list, a class list. Now let's transform the data frames into another data frames. Data frames are like tables. So just like using SQL, we use the select statement, we can use the same select statements here. So we create a new data frame called nameAge data frame equal customers.df dot select parenthesis first name, comma, last name, comma, age, close parenthesis, hit enter. A new data frame is created called nameAge data frame. If you do a nameAge data frame .show, you will see the new data frame with only 3 columns. Now let's create another data frame that holds the records for the customers over 30 years old. So we call it nameAge over 30 data frame equal to nameAge data frame, the data frame that we just created earlier, and put the condition where. So dot where age greater than 30, close parenthesis. So we have one extra quotation mark here. So let's close parenthesis now and hit enter. Let's do a show on this data frame to see that we only have customers that are over 30. One powerful feature of data frames is that we can perform multiple transformations in one line. For example, we can form the above commands that we just used in a single line. We can simply type customers tf dot select first name comma last name dot age. So let me copy and paste that here. Customers tf dot select first name last name age dot where age over 30. So all the separate commands are included here. If we do a show, you'll see the same results that we performed with multiple commands. We can also enter the data manually into a data frame instead of loading them from another file. For example, let's create my cost list. This is a list of customers, and type the list on the right side of the equation. Square bracket, another square bracket, put the list Mary Luthans, close the first record, Joyce Larry, the second record, Kathy Birch is the third record, close parenthesis, hit enter. Now let's create the data frame, my cost data frame, equal spark dot create data frame, and here as an argument we pass my cost list. Close parenthesis, hit enter. My cost df.show will show you the records. Notice that there are not labeled columns here. By default, it labels them with 1 or 2. If you want to change them, we can change the name of the columns by typing the following. My cost df.select 1, 2 dot with column renamed. 1 is renamed as name, 2 is renamed as surname. Dot show will show you that now we have the column names as name and surname. We can also save the data frames back into the cluster. For example, let's create another data frame called address data frame, which uses customers data frame dot select first name comma last name comma address. Hit enter. If you do address df.show, we will see the results. Now let's save this data frame back into the cluster. To do so, we use the write command. Address df dot write dot, let's put it back as a JSON format, so .json. And here we put the path where we want this data frame to be stored. We do it spark /dataframe /address list. Close quotation mark, close parenthesis, hit enter. Then the results should be stored back into the cluster. Let's do an exit. Hadoop FS ls spark tf will show you that address list is already created there. If you go inside the address list, you will see that we have a file called part/000. So if you do a cat on that file, you will see the results, the data frame saved back into the cluster as a JSON file. Finally, let's load a CSV file, separated values file into a data frame, and let's perform some more transformations. Type PySpark to get the Python prompt. Let's create cust df equal to spark.read.format parenthesis CSV in quotation marks, close parenthesis, dot option. Here we indicate that the header is true. That means the file has the header. We want that to be loaded. And we do dot load and put the path where customers.csv file is located into the cluster. Hit enter, and the data is loaded into cust.df data frame. Let's do cust.df show, and here are the results. There are multiple ways to access a certain column or a certain field in the data frame with Python. For example, customer.df dot select open parenthesis age. If you do a show, you can see the age. The same results can be achieved if we do cust.df.select, and age is called here as a column here, so the age column. So it can be called by the name of the column. If you do a show, you'll see the same result. Python offers another option. Simply type cust.df.age. If we create agedf, a data frame called agedf equal customer.df dot select first name, last name, age, where age is not null, customer.df dot age dot is not null, you'll see a list of first name, last name, and the age for the records that have no null value. So if you have agedf.show, the null values are eliminated. Only the first name, last name, and age of the customers who have an age value in the column will be shown. You can group customers by a certain record. For example, let's group customer.df by address. So customer.df.group by address. Let's count how many of them are, and let's do a show here to show the results. And you will see a list of addresses and how many customers live in each address. So these are some of the transformations and actions that we can do with data frames. We showed how to load the data frame from a JSON format or from a CSV format, how to perform some transformations, creating other data frames, and also how to perform some actions such as take, show, count, and so on. I hope you enjoyed these brief tutorials. If you have any questions, please feel free to reach out to me. If you want to learn more about big data analytics, subscribe to this channel. Also, follow me on Twitter at Professor Benny or join my LinkedIn network. You can always email me with any questions.